Hello everyone, in this presentation, we will explore the concept of address decoding, which is a memory interface design technique. Address decoding is a fundamental concept in digital logic and design, particularly when interfacing memory or input-output devices with a microprocessor. So, what exactly is address decoding? It's the process of selecting specific memory locations or input-output devices based on the signals present on the address bus. This enables the central processing unit, or CPU, to communicate with the correct memory location or device. Think of it as a way for the CPU to send a message to a specific recipient within a large network. Address decoding can be broadly classified into two main types: partial address decoding and full address decoding. Each type has its own advantages and disadvantages, which makes them suitable for different applications. Partial address decoding involves using only a subset of the address lines for decoding. This means that only the higher-order address bits are decoded, which creates multiple aliases for the same device. Partial address decoding is simple and cost-effective because it requires fewer decoder components. Here's an example of partial decoding using a 16-bit address bus. If address lines A15 through A12 are set to 1, 0, 0, and 0 respectively, and the lower 12 bits are ignored, then the device is selected for the address range 8000H to 8FFFH. However, due to the partial decoding, the same device will also respond to 9000H to 9FFFH, A000H to AFFFH, and B000H to BFFFH. This creates 4 aliases for the same device. In full address decoding, all the available address lines are used for decoding. This ensures that each device has a unique address range. The key advantages of full address decoding are that there are no address conflicts, and it allows for maximum memory utilization. Let's consider an example of full decoding with a 16-bit address bus. If all 16 bits, A15 through A0, are decoded, and the address lines A15 through A12 are set to 1, 0, 0, and 0 respectively, then the device responds only to the address range 8000H to 8FFFH. In this case, no aliases are created, and the device has a unique address space. In summary, partial decoding offers simplicity and cost-effectiveness, but suffers from address aliases and memory waste. Full decoding, on the other hand, eliminates address conflicts and maximizes memory utilization, but involves a more complex design and higher cost. The choice between partial and full address decoding depends on the specific requirements and constraints of the application. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.